In this video, we're going to discuss the power rule for indefinite integrals. So first, let's recall the power rule for derivatives. The derivative of x to a power is the power times x to the power 1 less. So the power rule for indefinite integrals is going to be an attempt to reverse the power rule for derivatives. So let's think of the power rule for derivatives as a two-step process. One, multiply by the exponent, and two, subtract 1 from the exponent. So to reverse that, we're going to have to first add 1 to the exponent, and then we will divide by the exponent. And this will give us the power rule for indefinite integrals or antiderivatives. Divide by the exponent. So this is going to be add 1 to the exponent, that's n plus 1, and then divide by the exponent, that's n plus 1, plus any constant. And the coefficient here of x to the n plus 1 is 1 over n plus 1. So we could also write it like this. Either way is fine. Let's look at some examples. If we have the integral of x to the 4th power, then we would get x to the 5th power divided by 5 using the power rule with n equals 4, and then plus c. The integral of x to the 7th power is similarly x to the 8th power divided by 8 plus c. N is 7 here, so n plus 1 is 8. So when the power is a whole number, it's pretty simple. Even if the power is a fraction, the integral of x to the 3/4, so we're going to use the power rule with n equals 3/4. We're going to add 1 to the power and then divide by that new power. So 3/4 plus 1 is 3/4 plus 4/4, and that's 7/4. And then we're going to divide by 7/4 plus c. And dividing by 7/4 is the same as multiplying by 4/7. So this is 4/7 times x to the 7/4. You can do division of fractions here with a keep the top, change this to multiplication, which is here, and then flip this one, and that's 4/7. So plus c. And the exponent can also be negative. Let's say we're integrating x to the power -2, so n is -2. Then add 1 to the power, and we get x to the -1. Divide by the power, we get -1. And this is the fraction negative from this negative here, and then 1 over x. Now these second two situations with a fraction here or a negative exponent here, those arise via different notations. So let's take a look at some situations in which those arise. Let's look at the integral of the square root of x. This is the same as the integral of x to the 1/2 power. So we're going to use the power rule with n equals 1/2. That wasn't obvious at first. We had to convert the square root into a power. So then this is x to the power, add 1. 1 is 2 over 2. So if you add 1, you get 3 over 2. And then divide by 3 over 2. And we could probably skip this step if we're good with our fractions. Then we will automatically keep, change, flip, and make it 2/3 times x to the 3/2. And you could also have a negative fraction on top of that. So we could have let's take 1 over the cube root of x squared. First, we'll get rid of the root. So this is the integral of 1 over, and the cube root of x squared is the same as x to the power 2/3. So let's recall the rule there. The rule is if you have the nth root of x to the power m, then the result is x to the power of the fraction m over n. The m on the top is an ordinary power, and the n on the bottom is the root. So here we had the third root, so the 3 is on the bottom, and the 2 is an ordinary power, that's on the top. And now 1 over x to the 2/3 can be rewritten as x to the negative 2/3. So now we have the power rule applies in this format with n equals negative 2/3. If we add 1 to negative 2/3, then we get positive 1/3. So the answer is x to the 1/3 divided by 1/3, which is the same as dividing by 1/3 is the same as multiplying by 3, 3x to the 1/3. And that's an easy one to convert back. This is 3 times the cube root of x. Let's try the integral of 1 over x to the 4th. This is the same as the integral of x to the negative 4. And then using the power rule with n equals negative 4, we get negative 4 plus 1 is negative 3. So we get x to the negative 3 divided by negative 3. And this is the same as this minus here makes a negative. And then our fraction, x to the negative 3 is going to move to the bottom. So we're just going to have 1 on the top. This 3 is just going to stay there. The 3 is 3 to the power 1. It does not have a negative exponent. It does not move. And the x cubed comes down. So the answer is negative 1 over x cubed. Let's look at the integral of x. That's power rule with n equals 1. The power 1 was not written, but it's there. So this is power 1, and the antiderivative is x squared over 2. So the integral of x dx is x squared over 2. What about the integral of x to the minus 1? The integral of x to the minus 1 is, if we use the power rule with n equals negative 1, we get x to the negative 1 plus 1 is 0. We get x to the 0 divided by 0. And that is not acceptable. That is not an answer. Division by 0 is undefined. So the power rule fails when n equals negative 1. So the power rule is not helpful here. How do we integrate this? Well, let's try it again. Let's take our integral of x to the negative 1. Writing it as a negative power did not help, as we just saw. So let's rewrite it without the negative power and just see if it looks familiar. So now we're looking for a function, an answer, where the derivative of the answer is 1 over x. And we know, I think we know a function whose derivative is 1 over x, and that's the natural logarithm of x. Now I'm going to write here natural log of x like that, and then I'm going to comment that this is still not the best answer, because this function allows x to be negative. X can be negative. And here, x must be positive. So this is not the best answer. A small modification is made. The integral of 1 over x dx, the best answer is the natural log of the absolute value of x. Now x can be negative, because when you put a negative number in there, the absolute values will make it positive, and then we could calculate the logarithm. But I also want to mention that the derivative of the natural log of the absolute value of x is 1 over x if x is negative. So let's suppose x is negative. then this derivative is simply the derivative of the log of negative x, because that's what the absolute value means if x is negative. And then from the chain rule, we get 1 over negative x times the derivative of negative x, which is negative 1, and the negatives cancel to give us 1 over x. So not only is the derivative of natural log of x equal to 1 over x, but also the derivative of natural log of absolute value of x is also equal to 1 over x. So that's the best answer. The integral of 1 over x dx is the natural log of the absolute value of x plus the constant. And this one is the exception to the power rule.